Swayam Prabha. Digital India. Educated India.
Welcome to this special series showcasing the work of SIH 2025 winners. Today we are going to speak with the innovators who have developed a solution for efficient energy use in iron ore mining operations. By integrating advanced technologies, data-driven insights and smart optimization techniques, they are redefining how energy is utilized in one of the most resource-intensive industries. Join us as we explore their journey, the challenges they addressed, and the impact their innovation could have. Welcome to the show, my dear innovators. How are you?
Yeah, we are doing great.
Good.
Thank you.
So, to begin with, let's know something about you first.
Yeah, so my name is Saksham,
And myself, Drishik.
and we are third year undergrads at IIT Kharagpur, and we are the winners for SIS 2025 for PS 25210, which is efficient energy usage in iron ore mine.
Okay, great. Good to have you here with us today. So, let's start by talking about the problem statement of yours. What exactly was that? What problem you were addressing in this particular competition?
This problem was from Ministry of Steel, specifically NMDC, where while mining ore, then during the comminution pipeline. So comminution means from taking out the ore from ore to final processing of iron, so that it is industry ready. It is capable of being used for different use cases across the country. So from this very start to the beginning, there are various steps involved. There is first taking out the raw ore, then there is processing, cleaning of that ore. There are various different steps involved. So these all steps combined called as comminution. So during comminution, there is a specific phase which is called crushing, where large ores which has been extracted from the ore has to be crushed into small pieces so that they can be transported easily, they can be processed easily. During that specific crushing section, there is a whole environment of, there is a crusher, there are different other machines, there are screens as in they filter out the smaller particles from the larger ones. So various different factors are involved in the bulk ore which is entering the crusher and a small fine ore which are getting out of the crusher. We typically call this as a feed and a product system. So we had to optimize that specific environment so that the energy usage can be reduced, indirectly kind of increasing the capacity that we can process and also reducing the financial cost.
Okay, so it is very energy intensive, as I can gather from your description right now. So, where did you begin? In terms of your research or in terms of your thought process, from where did you start when you start thinking about, conserving the energy and, optimizing it?
Coming from a mining background already, so we already had the ideas of how these machines usually work and what are the parameters that they depend on. First, we sketched out all the parameters that required more energy, and then we tried to optimize them first, like some in like how we talked about crushers. So we would take part by part of the crushers, and then we would think of where the energy is expended more, and then we would try to reduce the energy expenditure in that particular part. Like there is a series of machines that is in this communication circuit, so we would build a simulation, trying out different combination and trying out which combination gives us the lowest energy output possible. And also we would put it we would also test it financially and according to conditions, right? There are different conditions for different mines also, so we can't just put it into theory and just go with it. We also have to check of the physical conditions that are available in the mines, and to also test with that, like how is it even feasible at the location or not, and financially also. So in addition to energy also, we also try to uh, look at the financial perspective of it, like not in a point that reducing too much energy doesn't mean that you have to like reduce the cost to the lowest and use the cheapest possible like techniques or the machines possible.
So I'll come to two different points here to begin with. In terms of research, you elaborately told us how you went on about this. So you having a mining background really helped. I can see that. But at the same time, did you actually go to the mines also, or spoke with the people closely associated with the industry to get their perspective, to get their inputs? And if yes, what were those inputs?
So that's a really good question. While addressing these issues, what Rishik mentioned, that we were first trying to get through the overview, we were trying to look into small specific sections. And while doing all this, there is an idea which was also mentioned in the problem statement, that everything, whatever we try in the actual mine, has to be first made out a digital replica. So that is what is mentioned in the problem statement as a digital twin system, where we create the exact simulation of the mining environment. Specifically, we are focusing on the crusher environment into a software using different physics engines, and then we look after the changes in that section, and then whatever we get some data points, of course it's a synthetic data, but whatever data point we get from there, we just take that specific data and then test it out in the actual mine. So for in the beginning, we had various professors in our college who have already been into this sector for around 20 to 25 years. They have been working on various sections. So we reached out to them, asking them for mentorship, for help. We reached out to their labs where they are processing these different sections. We reached out to them regarding topics, that whether this is whether the ideas which we are proposing actually sounds correct and practical. Because proposing ideas such as Rishik mentioned, that they might be financially very good, but they might not be very relevant in mining environment where the conditions are very harsh. The incoming ore from the ground is pretty has a lot of moisture, has a lot of other components where it's not pure kind of. So our professor helped us a lot. He also referred us to various resources where we looked into and explored more of the different sections. So yeah, for actually looking into the practical section, we have been to the crusher systems, looking into various components, what components can be optimized. So that is the approach we took.
Okay, coming to the financial part of it. Okay, when you optimize energy usage, obviously you're going to, get a stranglehold on the expenses. You'll reduce them. But if we implement your systems there, that will also come at a cost. Is it very cost intensive, the unit, the structure that you have developed, or I mean, eventually it will lead to lesser financial burden on the miners?
Yeah, like to tackle this particular problem, like what we came up with is like a phased implementation system. Like since we have a new system to completely implement from the scratch, we won't like go on implementing the complete plan altogether at once, but we would like to like implement in phases. Like some phases may overlap each other and some phases may not, but these phase-wise implementation provides us that we do not exhaust our like we do not exceed our financial capability. At the same time, we are also implementing what we have created, and also we are trying to get old, like we are trying to synchronize the already old systems that are already there and already have like working present in the minds. So it would be easier for us in both implementation way and in financial way. So there are different phases, like for example, if we have 6 phases, so we can divide the what we going to implement and like how much financially we can devote to this phase, and we can tackle this problem of getting exhausted or getting like exceeding our like expenses that we are doing.
Yeah, in addition to what Drishik mentioned, just one point I'll try to add. So, while actually starting to implement the problem, after the first round, we were also given opportunity to talk to the NNDC team to understand more of the problem statement, to get more context of what actually we have to solve, so that we don't revolve around just the problem, but also get the core issue. So that is when we were also introduced to, there's a lot of other sensor systems which have already been deployed by NMDC. So one section of our problem statement also involved that collecting that specific data and providing meaningful insights so that those specific data coming from those sensors can be utilized to reduce the energy in the first phase. As you mentioned about, we have to incur some cost. So the sensors which have already been deployed, we don't have to incur any cost. The cost has already been incurred. We have already deployed the sensors. If we can generate more meaningful data, it's very good so that we can utilize those existing sensors. And as Drishik mentioned out, we were rolling out sensors in different phases where different phase was based on the importance of the sensors which have to be deployed. First phase would include the sensors which will improve the efficiency by a lot, because these are the primary sensors which is going to give us more parameters so that we can try and manipulate different factors to optimize the pipeline.
Okay, now I'll try to understand the entire flow of your working. Say I am a miner, I have a mine, and I am into that business, and you come to me to implement your system. So, what is going to be the flow of your work? How would you, put that in action?
Flow would be simple. So initially we started the solution to optimizing the crusher system, but as soon as we started exploring more sections, we realized that it should start from the very beginning where we take out the ore. It's not just at the gate where the various trucks like dumper, as in case of mining, which are large trucks which carry the raw ore coming from the mine into the crusher system. So finally, if I'm assuming a different mining owner who wants to implement this whole system in his mine, so something would start as initially, as soon as we do the blasting in mine is to break the ores from large bulky ores into small pieces, not very small, but maybe you can consider something like 1 meter diameter. Those 1 meter diameter ores now have to be transported to the crusher system, as I mentioned. So while blasting as well, we had built a system. It's more of a software which kind of optimizes how you blast. So while blasting, you have to use various high-grade explosives. You might have seen on the internet as well that mining is one of the environments where explosives are permissible. You can use those explosives to break down large rocks. So there are various design patterns, how you blast those ores, how you actually put those different high-grade explosives inside the mine. So we try to optimize from there. So from the starting end, if the design patterns are very good, we get consistent amount of blasted ores. So consistent amount of blasted ores, like let's suppose if we have done a recent blasting, if our blasted product has most of the rocks in the final product is around 1 meter, it is considered as a very good blasted ore, because the pattern should be very consistent so that it can be processed easily. If there is 5 meter, 3 meter, 2 meter, it's not a good blasted ore. Then we have also optimized this section of how various dumpers, where dumper as in trucks carry that specific 1 meter large boulders into the crusher system, in a way that these crushers only dump the ore when the crusher, the specific machine which crushes, is empty. So as soon as you blast an ore, the dumpers take that specific ore and it travels some distance across the mine. Crusher systems are generally at the edge of the mine, so they carry that specific from the core of the mine and transport it till the exact crusher where the crusher is. So if the crusher is already busy, there is no point to start the truck, take it to the crusher system and wait there till the crushing process completes. So the whole idea was that there was an interconnected notification system which makes sure that whenever the crusher is empty and it can process the next load, the truck driver will automatically get a notification which will include that, okay, you have to take this route and you have to reach in this specific time so that you can dump your specific load into the crusher. And then the parameters inside the crusher, that what should be the revolution speed of the crusher. There are jaws as in like large hammers kind of inside the crusher which actually crushes the rock. So what should the distance between those jaws that can be changed? The speed of the motor, or maybe if you want to upgrade the motor so that whenever there is no load available, no rocks available, if you reduce the speed, there is a less consumption of electricity. So something related stuff has been done from the end to end. So as a mining owner, you only have three different softwares. One is the optimization of the blasting. Second is managing the fleet as in the tracking system, how trucks will get them to reach. And third is what is happening inside the crusher. You can see that. So you only need to deploy some sensors inside the crushing environment and some tracking system across these trucks, and then you are good to go. You can use all these three services.
Right, sounds great. So now if I have to ask you, what impact do you think it's going to make on the mining industry as well as environment? So what would you have to say on that?
Also to like continue from the previous answer that Saksham gave, like starting from the blasting till the final product is obtained, it is not mandatory that since we are designing this whole combination system, that the product has to go through each and every machine that we have connected. For example, like if we get the final product size from the blasting itself only, then we can just take the final product out of the combination chain and just can directly use it, instead of like putting it through the combination chain again, and like which would generally result in more energy expenditure and also like over grinding of the product. So in case of our like how we implement the our solution, I think this would drastically like save time also, and it would also enhance the result, like the final product that we are obtaining, because we don't like we monitor each and every step in the combination line, and it's not like that we are just like sitting and putting on the blasted ore that we are getting into the crusher, and then we are taking out the whatever we get. It's like we are monitoring each and every step and each and every size that the product, like the blasted ore, is going through, and thus we can like save a lot of energy, I guess, through this. And financially also, if we like we know that a major part of the expenses of a mine goes into the energy expenditure. So I think in like cutting off the energy, like saving energy would give us a lot of savings alone. And apart from that, we also developed a fleet management system like the trucking and all. And also a part of our solution also included that we would like develop some ideas, like in our solution we should develop it in a such a way that we should include some renewable energy sources, in which we also try to develop some that like our complete combination system to run under solar energy and wind energy. In case of open cast mines, or in case of underground mines also, we can just store those solar or wind energy or hydro energy, and to like in these renewable sources will have like a good impact on the environment as well, and it will help in much more savings in case of financial and energy expenditure also.
Great. I think that's wonderful. At one end, we are trying to conserve energy, and at the other end, we are using renewable energy to just bolster the entire effort. That's wonderful. I mean, both the things combined together is a wonderful idea. Great. So now let me have some idea about the experience that you had at SIH. What kind of challenges did you face? The judging rounds, how were they, and how did it come across to the judges? Their feedback, and everything that you would like to share with us.
The experience was really good. First of all, thank you to the SIH team for really good curated problem statements, which pushed us to explore various domains. And of course, it's more of inter-domain as well, because renewable energy generally is not a part of mining engineering. It's like energy system. So we had to go out of the box, think some what type of different measures currently different mines are taking, what we can also propose in our idea, how it fits into our specific what idea we are proposing, as well as various different interconnected systems, so that we can explore every section. So really, thank you to SIS team for very good problem statements. Again, the section of how we actually felt around throughout the process, it was more of challenging initially, where we were exploring the process statement, we are having different thoughts, brainstorming on what should be present, or whether we'll have we'll have counter questions of this topic, what we should keep it on our PPT, what we should keep in our report. So that was a really good experience uh, from my perspective, where you have to think in different perspectives so that you can also back some resources to explain why we did that, and you also have some experience in terms of how you build a entirely new system from the very scratch. In consideration towards the judging panel, I think they were really great. We also connected with some of the judges before uh, the actual competition, because I already mentioned that we were initially given some mentorship rounds where they were explaining us what they actually think the solution is. They also promoted us in various ways, stating that you should also think some in this direction while we were trying to find some different answers. They kind of made sure that the path doesn't get deflected. We work on a specific path which actually leads to a good solution. And during the actual SIS V-Day as well, we had lots and lots of mentorship rounds. After every judging round, we had a mentorship round where some of our mistakes or some of whatever we have said was being cleared. We were asked to add some other features which will make the solution more appealing. So I think from an overall perspective, with the judging round, they were really great. From the problem statement, solution, what they told us about the future aspects of our solution, what we can improve. I think that was really great. Yeah.
To know the experience that you had at SIH was very fruitful, and of course the professionalism that you have shown throughout this journey and the impeccable solutions that you have come up with, which are not only technically sound but also very mindful. It's really appreciable, and I congratulate you once again on winning the competition, and I wish you all the best in your whatever future work you do in this particular direction or any other direction of in terms of innovation. My best wishes are with you, and hope we'll see you as innovation stars of the country in the coming few years, if not less or more. Thank you so much for joining us today and sharing your project with us. Thank you.
Yeah, really thank you for joining.
These young innovators remind us that meaningful change begins with bold ideas and a commitment to progress. Their work stands as a testament to how technology and vision can come together to address some of the most pressing challenges of our time. Thank you for joining us today. Stay tuned for more such inspiring stories of innovation and impact.